Hallo und herzlich willkommen zur heutigen Ausgabe der Windows Server Show, der Nummer 5. Es geht heute um AMD-powered Solutions für tägliche Einsatzszenarien mit Windows Server. Heute habe ich den Manfred nicht mit an Bord, aber ich habe einen ganz tollen Gast gleich, den Alexander, den ich kurz dann gleich vorstellen werde. Aber zunächst sei gesagt, die heutige Session findet statt in englischer Sprache, weil Alexander des Deutschen nicht mächtig ist. Aber ihr könnt natürlich trotzdem jederzeit Fragen stellen, gerne auch auf Deutsch. Ich bringe sie ihm dann gerne übersetzt oder eben direkt auf Englisch. Ansonsten könnt ihr natürlich die üblichen Übersetzungstools gerne nutzen oder wenn ihr das dann später mal on demand anschaut, gibt es ja auch Übersetzungstools auf YouTube. Prima, dann würde ich sagen, hole ich den Alexander jetzt mal auf die Bühne. Hello Alexander, how are you doing today?
Good morning, Sven, und herzlich willkommen zusammen. So all good, all good. My German is not as good as my English, so that's why we're doing it in English. But I hope one day we'll do it in German fully. So let's see. But I'm doing well, Sven. Thank you. And how are you doing today?
Well, I'm doing fine. I'm curious about the content you are going to present today. I think I will relax and listen to you and learn a lot. So I would like to hand over to you and maybe you introduce yourself at the beginning and explain a little bit what today's session is about.
Absolutely. So first of all, Sven, thank you for having me. And today will be all around the benefits of AMD, specifically, or why AMD for Microsoft Windows Server solutions, or generically for data center. So whatever it's a small data center or big data center, anything we can bring from AMD's perspective, that's what the session will be about today. And so my name is Alex or Alexander, whatever you prefer and the audience prefer, totally fine. And I'm the product marketing manager for AMD EPIC, which is the server CPUs we have in the portfolio of AMD products across Europe or across EMEA. So I'm part of the server business unit at AMD. And I hope to make this session as useful as possible for anyone who is joining live or watching on demand.
I'm pretty sure about that. So we met each other at the hybrid conference in Würzburg in November, and I listened to you and I was absolutely, I like your session very much because you have a good combination of the way you're presenting it and the content you had, and it was very nice. But at the beginning of your session, you mentioned that usually you need a little bit more time than 20 minutes, so 45 would be perfect. So I thought about bringing you to this show, and today you have the full hour if you want to. And start the show.
Sure. So this is then the agenda for today. So I prepared more or less, as you mentioned, Sven, an extended session as to what we had in Würzburg. And we'll go through kind of a journey of AMD in the data center. Why is this important? Because I'll show you exactly what we're focusing on as the company when it comes to the market and when it comes to the products. So we'll show you also the product series, because we have multiple product series specifically in the portfolio of server CPUs and their benefits. And also just a very quick high-level technical overview of all of them. Then we'll go through the solution portfolio simply, and I will flag out also the Azure local certified platforms we have with our partners and vendors across in the market. We'll talk more about the optimizations for every business need. I think this is coming back to the title of the session specifically. And obviously, I'll go through the performance benchmarks and simply how to define, or how we define, the value and how we see it really resonates in the market with customers and partners. So that will wrap it up with the TCOs, different scenarios, and also show you a couple of tools which anyone who's joining the webinar, or anyone out there, your friends, your colleagues, can use without any restrictive access. So we do have some very useful tools how to calculate, for example, TCO, and I'll show you a quick brief demo, you and everyone else who is joining, of those tools. I find them extremely useful and think it's a good investment of a couple of minutes to do so. How does it sound?
Sounds good.
Good. So let's jump right into that. AMD is well known, I think, in the industry, and it's well known across multitude of customers, partners, vendors, and so on. But not always people know what is our underlying mission or where we're focusing on. And so as AMD, we believe, obviously, that high-performance computing and adaptive computing are changing people's lives. And our goal is to namely enable the solutions to the world's most important challenges. And that's a very big marketing slogan. But in reality is building the best product out there. So, and delivering the best value and the best performance to our customers, to our partners, to the whole ecosystem. And so this is just a couple of highlights as to what we have right now and what's going on in the market. And I mean, this is the HPC focused kind of two pillars, right? So there's the HPC top 500 list, which is the fastest supercomputers in the world. And we power the number 1, number 2, and also the good amount of the fastest supercomputers in Europe. So the number 1 and number 2 are in the US. At the same time, across 8 years of the roadmap and across the 8 years of 5 generations of products, we now power more than a third of the top 500 list, which is quite impressive. And then at the same time, we do power world's most energy efficient supercomputers. And we have 26 systems in top 50 list, which is, again, quite interesting to see from the lens of perspective of balancing performance and power. So going into the energy efficiency, but we'll talk more about that. Won't talk too much on others, especially on the GPUs. We are one of the 2 providers offering the GPU solutions out there. The likes of OpenAI, Meta, and others are using our GPUs to bring the services out there to the market. But this is an interesting part. We have been, for quite some time, the number 1 default choice of the CPU for hyperscalers. And we do run multitude of mission-critical workloads for them. That includes whatever you want to name, Zoom calls, Teams, cloud, search, everything. And that's quite exciting. So I'll show you also how we go through the market share and generically through the different generations of products on the next slide. But this is a key quick summary as to what AMD is. It doesn't stop there, right? So this is AMD in the data center. If you think about the client devices, if you think about the gaming, that expands into even more products and even more fun stuff, from Xbox to PlayStation to cloud gaming, whatever. It's a lot of fun stuff in the industry and a lot of fun stuff in the AMD-Portfolio to enable our customers, partners, and the whole ecosystem, as I mentioned. So, but this is just a quick summary on the data center part. So with that, we have been growing the market momentum. And again, this is the market share slide, but I don't want to talk about the market share. There's something else on this slide I want to talk about, and that's the relentless execution. So we launched the first generation of AMD EPYC, so our brand new server CPUs, right? So the server CPU lineup in 2018. We brought the product to the market pretty much having 0 market share or close to 0 market share. In those 8 years, we have executed 5 generations of the EPYC products already, with the 6th one coming this year, publicly announced as the codename Venice. It's not on the slide, but that's, again, just a quick announcement out there. And our goal is to deliver the products as promised and on time. And that has happened so far, and that will happen in the future. So this is the commitment of AMD towards the data center market. And the market share reflects the resonance which we see from end customers, from partners, from everyone out there, from the users of the application, whoever. So right now we power more than 40% of the world's servers. This is the market share, as you can see also in the source materials based on revenue. Regardless, that includes the hyperscaler business as well. So it's everything together. And we power every workload you can imagine, from the digital services to the enterprise workloads, and we'll talk even more about that through the course of today's session. But that's an interesting lens perspective as to commitment to the market. Market share is a good result out of that, I would say.
Yeah, that's really amazing. So I remember beginning of the COVID times, Manfred and I had first collaborations with AMD. So this was around about 2020. So we're talking about the 8% market share. And I remember that we had this special AMD Windows servers queue with different regulations on the core count. And in the meantime, a lot of things happened. And I remember that in Würzburg, you asked the audience how many people have experience with AMD in their Windows Server. And what was the amount of hands going up?
Somewhere around 40%, which was quite funny. So it's like 40%.
So,
yeah, it's pretty much there.
Well, that's good. Perfect.
So I think how to build up on that, right? So this is, again, more of a marketing slide, marketing slogan. But as a technical person at heart, I want to touch upon the technology as well, which is beautiful. And what I mean by that is this is a quick summary of the same 5 years, but through the lens of the architecture design. So what we use in AMD EPYC CPUs, that's data center, and AMD Ryzen CPUs, that's more of a client devices, so desktop, laptops, and so on, is the Zen core architecture. So Zen is just the code name of our architecture, which is used for the server CPUs, server client CPUs, specifically the core architecture. And then it has 3 pillars. It's scalability, performance, and energy efficiency. What those pillars mean is what we focus on when designing the new chips all the time. So finding the right balance and scaling all of those 3 pillars to the maximum, to the extent we can at a particular time. And this slide talks exactly about that. Scalability, performance, and energy efficiency, but through the lens of the 5 generations of the EPYC products, what we were able to do in those 8 years. And you rightly mentioned, so this was the 32 core segment. When we launched the CPUs initially, they were scaling up to 32 cores. Then the second gen came in and it was 64. So one of the fun stories out there, and this is what we talked also about in Würzburg, is when we launched the CPU, so it could scale up to 64 cores, that's going to be 128 threads. And if you then multiply it by 2 sockets, that's 256. And in some cases, we obviously needed to work with the ISV vendors to make sure that everything is visible in the system. And I think on Microsoft Windows Server, what happened in the very, very beginning, the system could not see all of the threads available. So that's coming back to the point of scaling the products and working with ISVs and making sure everything works in sync, which is something we've learned a lot from throughout the years. But from the product perspective, again, scaling even further now with up to 192 cores. And I'll talk about this. This is not the only CPU we'll have. It scales from 8 to 192 and everything in between. This is important, considering the licensing as well. Then scaling the performance by more than 11 times, and at the same time, pushing the energy efficiency or performance per CPU energy used by more than 4 times. And that's exciting. So combining all of those 3 together, of course, the scalability does impact the performance, but also within the same core count, providing even more performance per core is extremely important for a multitude of different workloads and different applications, which are single thread performance specific, right? So which might not scale that well with simply cores. So with AMD, you get the best of all the worlds. So best scalability, best performance, best energy efficiency, best performance per core, which is something I will definitely talk about through with details today. But this is exciting. Like, to me, whenever you have a product which is pushing the envelope of 50% more scalability, 70% more performance, 25% more performance or energy efficiency within generation to generation, that is exciting. And that's, I think, the beauty of having the modular design we have and having the very strong focus on the data center market within, obviously, AMD strategy, which leads to all of those results. So I've been around since the first generation. So I have covered the AMD product since then, and it has been a very exciting journey. I'm just waiting to see also what's next and see what we can do across the ecosystem with the customers in Germany, with the customers in Europe, as I'm focusing on Europe, because it's exciting. With that being said, that's the benefits and what we're focusing on, where we focus, where this focus then translates. And that's into, obviously, the products. So here you have 3 series of products we have. So I'll tell you also quick marketing overview as to what we position those products for, and also the quick technical summary on the next slide of all of those generations, or series, sorry, not generations. And then this is the whole portfolio of the CPUs, the server CPUs we have, and we have respective platforms also available with them. So the 4000 series is the very entry product, which is attractively priced, but still delivers significant performance, especially significant performance per core. I'll also show you exactly why. So 8000 series is more positioned for intelligent edge applications. So it's somewhere in between 4000 series and 9000 series, providing decent performance at outstanding energy efficiency and optimized per space. So this is what we usually position for the data center deployments, specifically at the edge, from, let's say, retail supermarket down to the factory floor. So everything in between. And telco, somewhere you are not able to utilize the large scale rack deployment or data center deployment. So this is the product for that space. And 9000 series is the highest level of performance, the highest level of scalability you can get. So it's the optimized solution for the most demanding workloads. But at the same time, it's not just the most demanding AI workloads and the biggest data centers. It's the standard form factor data center product we have with our partners as well. I'll give you all of the details about all of them just shortly. And this is the quick summary of the series. So we have a pretty wide portfolio coming from the entry space to the top tier performance. And this is what I mean by that. Same slide, but in here you have the key summary of technical details. So which is important whenever you go, for example, to Azure local sizing, you will see the recommended platform, so you can easily match it towards the generation and towards the series of the CPUs we have, which is, with those technical details, it would be quite useful and quite easy to do. So the 4000 series scales from 4 to 16 cores. And if you think about it, from the SMB size type of deployment for small installations, going up to 16 cores with Windows Server is a good way to go to optimize the licensing costs as well. So it's one socket only, has 2 memory channels only, so not a very large footprint of memory, and a small amount of PCI lanes. But again, whenever you don't need 4 GPUs in the system or 20 NVMe drives, it's a good solution. So we utilize here the cores which are very close to performance and even slightly higher, which versus our client and desktop products, so the Ryzen series. And even from the technical perspective, you will see they're quite similar. So from the core counts, from the memory channels, and so on. So it's a very similar space, but what we do here is we put more server-grade certifications on top of those CPUs and work with the ecosystem to enable this across the space. So for example, it's part of the Windows Server HCL list or Windows HCL list. this is just one of the examples. 8000 series scales a bit more. So it's 8 to 64 cores. It's 6 memory channels and 96 lanes of PCIe, which is pretty significant. It's only one socket again. Still, it gives you quite a lot of flexibility, and it actually makes a lot of sense, again, in different type of deployments, whenever you don't need all of the big stuff. So it gives you a good balance between performance, power, energy efficiency, price, space used, and everything. And so 9000 series, we can say flagship product we have, scales from 8 to 192 cores, which is a lot of cores. And it has also an expandability into the second socket. So you can use 2 socket CPUs, and it has 12 memory channels per CPU. So in the two socket systems, it's 24 memory channels, which is quite a lot of memory. And then it scales up to 128 PCIe lanes in one socket and up to 160 PCIe lanes in 2. And that's what I mean by that. Like if there is a need or requirement, for example, for VDI to put a lot of GPUs in the system, you can use both 8000 and 9000 series. It's just the scaling is different, right? So the number of devices you can put within the system on the 9000 series is higher. Simple as that. Plus you can add NVMe drives, plus you can add any type of other peripherals, whatever it's networking card or something else, and you get a very beefy platform. But as long as you don't need it, there are other series too. So we try to find the right product for each and every type of customer. That's a quick summary. So how does it look? How does it sound, Sven?
Well, it looks like that you have a solution for every scenario in the market.
I'm glad that you think this way, because I think the same. and it actually builds up perfectly into what I'm about to present in the next couple of slides, which is the portfolio of solutions. So it goes all across the spaces, right? So I know we're focusing on the Microsoft and Microsoft Windows Server today, which is why I'll focus mostly here, right? So what we have as on-prem solutions, on-prem servers, and we basically have a multitude, so over 450 server platforms based on different series of processors across all of the ecosystem. Whenever you're looking for an HP platform, Lenovo, Supermicro, Dell, Cisco, whenever you're looking for the ODMs, ASRock, Crack, Tyan, Gigabyte, and others, we have a very broad portfolio of solutions. And so in numbers, to give you another perspective, like this is the OEM portfolio, right? So in different type of systems, across different generations available out there. I also have a slide, it's saved a little bit towards the end, which will give you a quick summary of the Azure local certified platforms and the hardware list with across those OEMs. So we can talk exactly the details and examples, but in general, we have the platforms. So whenever whatever customers are looking for, I'm sure we'll be able to find the right sized platform and the right sized CPU for them, which is again, to me, quite a good value proposition, quite an exciting time. Because as you can imagine, coming from the first generation, this has not always been the case. So now we are positioned very strongly out there. And as we talked a bit about the certifications, the workloads, and so on, just to give you a bit of a background and reassurance, I would say, to anyone who is joining, right, as to will my workload run on AMD? Whenever it's a specific application people are using on top of the Windows server or specific, again, modeling or simulation applications used within the VDI space to provide the access towards the scientists or the ultimate knowledge users within the company, in 99% of the cases, it runs perfectly well. And I will explain what this 1% also means. But in general, whenever you're choosing AMD EPYC, it's an x86 64-bit processor, which is de facto a standard in the industry. So we do have some other architectures out there, but the majority of stuff running in the world is x86. So in fact, the 64-bit extension to x86 has been developed by AMD long ago. It's called AMD 64. And then it was adopted by the broader industry. And we even have right now a joint, let's say, x86 advisory board together with Intel and other parties to make sure that x86 ecosystem has very high level of interoperability and transition between different workloads and the optimizations. So with that being said, though, when it comes to the server CPUs or when it comes to the CPUs overall, all of those workloads in here, or applications, whenever you're looking into the traditional operating systems, Windows Server, or you want to go through Citrix or Canonical or Red Hat, whatever, or databases, whatever, or database analytics, whatever you do look in SQL or another way, or HPC AI, whatever applications are there, they run perfectly well on AMD. There are cases where software is not certified for AMD. There are cases like that. But in general, across majority of scenarios, the workloads run totally fine. If you have in-house code, and so in-house developed applications, we have the transition libraries and also software tools to help with compiling and to help with optimizing the performance and simply running the workloads on AMD. But in general, regular customer doesn't need to worry about running stuff on AMD. It runs perfectly well. And so with that being said, Microsoft Windows Server, SQL, everything runs perfectly well on AMD. And we have a bunch of world records I'll touch upon as well in this space too. So it's not coming just without the reason. So there are a lot of reasons behind that. And in fact, just another statement towards the interoperability and another statement towards the different workloads is all of the various different customer names you can see in here, which are choosing and using AMD EPYC. And the fun portion of this slide is not about the big names and the greatness of the different customers. It's actually verticals to me. If you think about it, there are some workloads or applications run uniquely in particular verticals. So there are specific applications in the FSI space or financial sector. There are specific applications in manufacturing. There are specific applications in the software development, in CDN, for example. So more of content delivery networking, more of the entertainment space. So there are particular workloads in each and every space. So this is another statement as to we run well across all of them. So what you can see on the slide in here is everything across the digital services to F1, so racing, to manufacturing, to defense, to digital services, to chemical, to, automotive, everything. And that's coming back to the specifics of the workloads and that it all runs well on AMD. So this is just a quick summary. So we are 10 right now. I think it's a good time to jump into all of the different calculations and examples, and finishing up and wrapping up with the story. How does it sound, Sven, to you, or are there any questions from the chat so far?
There are no questions so far, but I like the story very much. And if I look at all these brands, I see that those brands are very familiar with the Azure Local story. So a lot of these brands are using Azure Local. They are first to market customers when it comes to new technology from Microsoft. So it looks like that those customers also understood the benefits of AMD and of new technologies from Microsoft. So they are very innovative.
I agree. I think so too. So with that, this is a quick summary slide as to all of the benefits, what those customers have been seeing. And this goes across different spaces, and I'll touch upon pretty much every one last of them during the course of the last, say, 30 minutes or so, maybe 20 minutes, we'll see. And that goes from the simple cost reduction, whatever it's, for example, reducing licensing cost or providing more performance, power efficiency, so reducing the electricity bill, consolidation, so more VMs, for example, at less power per server or per installation, depends, and generically providing the higher performance per dollar or higher performance in general. It really depends on the particular customer space or example. But this is just a couple of quotes out there from the public cases or references we have, which are all can be publicly found online with the references, and some of them are also using local, so Azure local with AMD, as you mentioned, Sven. So we do have cases like that too. But this is a quick summary. So we'll go through each and every one of them. But I think, as I mentioned at the very beginning, so the three pillars we had is scalability, performance, energy efficiency. This translates in here to all of the benefits straight away, but I'll give you exact kind of the way to calculate it and exact the way how to perceive it as well, from the performance benchmarking to pricing to TCO through the next couple of slides. So with that being said, this is, I think, a very good summary as to we can deliver any optimization for every business need, which is extremely important right now, considering all of the, the cost increases in the industry, whenever it's the energy simply, whenever it's our electricity across Europe, Germany. I think it's very important and popular topic, down to the increased price of components. You always want to find the best scenario for you, or the best performance or the best value for the euro or for any type of currency you invest. And I believe strongly that we can provide the best out there. So won't stop too much on this slide. So this is just how the CPU looks like. And this is the 5th generation of the CPUs we have. What I wanted to show also is not that this is the world's best CPU for cloud, enterprise, and AI. Yes, we think so. And I'll give you exactly the benchmarks of why we think so. But I want to remind everyone that it's not just the 192 core CPUs we have, it's everything in between. And so we provide, I think, pretty lean product stack across any type of product series, which goes, 9000 series goes from 8 cores to 192, and you have all of the different other choices as well, right? So from the scaling capacity and capability, whenever you also go into the Azure local sizing, and whenever you size the system for the workloads, right? So for whatever it's for VDI, for general, for database, it will give you a recommendation of the CPU straight away across the generations too. But just don't forget, like, it scales a lot. So a lot of people who are joining even this call might never need this type of scaling, right? So somewhere in here, usually a sweet spot, you have the best, I would say, the best balance between all of the technical features and scaling and performance per core. So also, even if you think about frequencies for VDI, this goes 64 cores at more than 3 gigahertz base. That's pretty good for VDI. But in general, we offer all of the different choices. But most importantly, across all of those different choices, all of the core counts, we offer the best performance per core. So we offer the best performance overall within the core count, but this is a comparison of same core count across the space. And we can scale to the areas where our competition cannot, but at the same time, we offer the best performance per core across all of those spaces. And this is, again, back to the point of the relevance in the industry right now. Whenever you're pressured from the pricing, like the cost perspective, right? So you want to find the best deal. What is the best, which can deliver the best value for you out there. So across all of the core counts right now with the 5th generation, we can deliver the best value. This also goes better with performance per watt, because usually the wattage or the energy is very comparable across the spaces. I'll show you some other benchmarks around that as well. But we offer the best performance, best scalability, and the best energy efficiency at the same time. Which is, again, coming back to the architectural perspective, this is the real result out there. And by the way, anyone can find all of the details behind what has been measured on this benchmark publicly. With which vendor, what is the results, it's all publicly available. It's the industry widely used spec rate, spec benchmarking. This is integer, which is more relevant to the enterprise space. But this can be found publicly. And I even have a tool which helps to find it quicker. Like you can find it on the spec website, but it has a more comprehensive search, I would say, where you need to search, like you need to know specifics. But we have tools to help pull information from spec website much easier and faster. So whenever you're looking for
cool overview, really.
Yeah.
So if you look at the AMD solution at 24 cores, for example, they are more performant than the Intel solutions at 32 cores. So from the Microsoft Windows Server licensing perspective, you save 33% of licensing cost if you are using the smaller version of the AMD compared to the higher ones of Intel, with more performance on the AMD side. And you can do this math on almost every scenario. So from licensing perspective, that's really impressive.
And I love that you bring it, Sven, because this is the underlying key value as well. Not just within the core counts, but also scaling back forth, it just finding the right balance. We can optimize a solution whenever it's for virtualization, whenever it's for particular workloads, even scaling down the core counts and providing the same or similar level of performance. So you're totally right. So this is another way of looking into the benchmarking as well. Again, I'm usually asked about specific workload performance. Will this perform better? And it sometimes is very hard to find publicly available information, because I prefer and enjoy referencing things which anyone can find and not hiding behind a special like footmark slides. In here, there's even a link to the source, right? So this is a Phoronix, so the third-party testing, Phoronix benchmark, which runs geometric mean of like 140, I think, of 144 workloads. Obviously, the higher result is better. And they do everything from like blockchain, database, rendering, virtualization, a bunch of other stuff. So a multitude of different workloads. And you can find the results for each and every workload out there on their website. So this is what they've compared at launch. And we can provide, again, at the same core count, much higher performance. So this also goes into comparable power, pretty close. We do consume less a bit because of the chipset and some other technical details, but I won't go into there too much. But at the same time, you can scale down the core counts in case this is possible for the workloads and for the installation, providing the same or even more performance again. So this is quite interesting if you think about it from the balancing perspective and different workloads. And this is the result, average result across multitude of workloads. So, and this is important reference. For the same reason, we have over 500 different performance world records out there across not just one set of workloads, but multitude. So whenever it's database, SQL is included. I mean, TPC is included, specifically ROC, but it's referencing SQL performance, virtualization energy efficiency, integer performance, Java, HPC, whatever you want. Like this is all also publicly available as references on the website, on our website. So all can be accessed. We're happy to provide any type of links. That's not a problem at all. Or just search for AMD Epic World Records. You will get to the page straight away. So that's, I think, pretty straightforward. And so just to give a very specific example as well, once again, this is like, if we look into the few of the dominant open source data management software out there in the market, we can start easily with MySQL. And it's one of the relation database management systems out there. And this is what we are able to scale also throughout the core counts and throughout the generations. So this is one of the top SKUs we could provide in the previous gen and how we compared before and what we can do now. So, and the same goes for the TPR OC benchmark workload. So it's the OLTP brokerage on SQL. We can just simply provide, again, across the same core count, more performance. This is the total system core count, but it does matter. And so it's always a balance between what you need, what you can use and reference like effectively. And so we have solutions across all the different core counts and across all the different platforms which customers might look or need. So the two last things I want to show you quickly is the TCO scenarios. And this will reference, Sven, what you've said in terms of the saving money on licensing or optimizing the number of licensing used. So I'll show you 4 TCO calculations overall, and then we'll give you a quick sneak peek or summary of Azure local certified platforms before going into the tools and wrapping up the session. But as the TCO, so we'll start, I would say, relevant with a small size case scenario. Maybe 10 servers is a bit too much for some of the people, but you can always run the same type of TCO estimations on a publicly available tool on our website. So I'll give you also the link of where to find it. This is what I've compared. Simply, I have 4 scenarios, small, medium, large, and scale, across the same core count. And this is the value we can provide. To achieve the same performance, that's the logic of the slide, to achieve the same performance of 10 systems, we need 9. But it's okay, servers, number of systems, okay, fine. But this is the same core count. What does it then mean? That's 10% fewer per core licenses if you license software per core. So if it's socket-based licensing, then you can even scale higher. It really depends. I mean, in socket case here, it's also is going to be lower because it's two less sockets, because it's 1 less server, 2 socket server. It's straightforward. At the same time, you do provide the required performance, but at the same time, you use less power. And it all comes down to driving the total cost of ownership of the solution, which includes the management, hardware acquisition, licensing, and everything else, down 10% across 3 years, which is quite good. But the further you scale, the more the benefits will be visible. Like the more you will be able to then save, obviously. And so this is the medium case scenario with 30 servers, so quite a large installation with 32 cores. Same core count, you can drive the number of servers down 8 server and number of cores at the same time, respectively. So that gives you same performance at 27% fewer per core licenses, consuming 22% less power. So if you combine it all together, driving your electricity costs down to power the data center, and then driving your licensing costs down, but providing the same requirement you have for your end users, for example, in the company, or even if you use it yourself, right? So you have an installation of a couple of servers, you now have a direct benefit. So yes, it provides more performance per server, but this is how you get down to lower amount of servers. But in general, this logic works in each and every case. So 48 core, same type of story. The numbers would differ, yes, because there's different number of performance requirement, different performance per CPU and per server, yes. So it's not holistically the same because you consider power as well there. But same goes for 64 cores and everything in between. So you can scale higher, you can scale lower, depends. Anyone can do the same scenarios by themselves at any point in time using the server TCO estimation tool. So I have a link out there. We'll share it. Maybe Sven, we can put it in description or comments. So that's not a problem at all. There is one page which has 3 tools. One of them is cloud specific, and one of them is server CPU. So CPU choice or select a tool. And then there's a TCO tool. TCO tool gives you exactly that. And you can compare it using the older generation products, the new generation products, whatever is available out there. So it's really powerful, free, and anyone can access it tool. And you can get all of this information there based on the specific case of yours. Or if you're a partner, for example, working with the end customer for their case, it's all possible out there. So in fact, if we have a couple of minutes, I can easily demonstrate the tool as well towards the end of the session. So we can do it that way. So randomly popping up the tool and seeing where it leads us. So with that being said, this is the different TCO scenarios. I think it sounds and looks extremely attractive. If it's not the case, feel free to drop me a note or call me so we can discuss. But this is the value of AMD. Like, this is what we can provide. Everything, as I mentioned, so performance, energy efficiency, scaling, whatever it is, this is de facto a value and I would say user from a perspective of the infrastructure acquisition will see, and also from the perspective of the user application, as we have on average higher frequencies and higher performance per core, that's direct impact on the application user experience as well. So it's all pretty cool. And this is where you can find it also on Azure Local. So I promise to bring it up there. So we do have an integrated system. By the way, both of those systems are based on the 8000 series. So slightly lower scaling as to what I have showed you with the 9000 series, but still pretty attractive. And we have an integrated system with HP, and we have a premier solution with Lenovo available out there on those 2 systems. Everything else is the validated design. So whenever you go into the sizing, whenever you go into the catalog, you will be able to see all of that and even more. So this is kind of the ending point in terms of portfolio. And the last thing I have, Sven, unless we have any particular questions, whatever technical or sales, it's just the tools. What information is out there available to help whenever you're a partner or a customer, to help you navigate the epic journey and even sometimes optimize the performance on the system if it's technical, or simply get more information. This is a quick summary slide of all the tools available. And if it's not a problem, we can just put all of them or some of the critical ones in the chat so anyone can access it straight away.
Absolutely, we'll do that. And with the LinkedIn post I used to promote the session, I already shared the link to the Epic website where you have all those tools included. So very, very nice tools. I already tested them, and I invite all of you to do that to get a clear idea about how performant AMD Epic solutions are. And it's a bunch of interesting information on that website, but I will repost it after the session so everyone has access to it.
Sounds perfect.
Sounds great. Yeah.
So should we then take a couple of minutes so I can quickly guide people as to how those tools work?
Yeah,
and will take me, sure. It will take me for 2 of them, I think total of like 14 clicks. So it's pretty good, I would say. Pretty fast and pretty easy to use tools. Let's see if I pull the window out there, I think you will be able to see it. Yes. So as a quick demo, let's say we do Epic, so AMD Epic tools. Processor tools, you can see it here. Easy as that. So you go in, you see the page, same as it was in the screenshot in the slide. There's a server TCO advisor tool, which helps you build the TCO scenarios, as I mentioned. There's a process selector tool. And there's also Epic Cloud Advisory tool. We'll touch upon those 2. And the first, I'll start with the processor selector tool. It's the tool used whenever you are looking for a specific processor. When I was thinking, what was the recommendation from AMD? I compare it with this, and this is the tool, like how the tool works. Choose the competition, so choose our competition processor, whatever you're planning to use or have been using before, doesn't matter. Like 1 stands for 1 socket, 2 stands for 2 socket, straight away. So 2 clicks, select the generation of EPYC, so the last one is 9005. 3 clicks, compare it to 1P or 2P, so 1 socket or 2 socket systems, submit, you get the recommendation. That's it. So in here you have usually multiple comparisons, if that's available, with 48 cores specifically here. That's only one. But you have the performance in here, you have some of the other details. If you click on the CPU in here, you get to all of the technical details of the CPUs you can check and see by yourself. And if you go in here, you can actually access, both for us and the competition, the spec results as to where it's coming from. And this is, so the system will pull out the top result available always. So what is the highest performance you can go? And you can see all of the details out there with the source file. So again, it's using the publicly available information in data. And if you want to choose something else, again, same story, quickly, boom, boom, it gives you a summary. Pretty easy to use tool. If you obviously need more help or have questions or feedback, feel free to get in touch with us, get in touch with me directly as well. Up to you. Always happy to help. But this is quick 4-click summary of the processor selector tool. Pretty straightforward.
It includes the pricing of the CPU, I see, so that's good to see. So it's a list price, I guess.
Correct. It's the 1KU so-called pricing or public pricing you can find also on AMD website or anyone else. Obviously, the real pricing highly likely will differ, depends on the particular scenario, deal, configuration, I don't know. But this is, again, what publicly is available. This is what we can compare easily.
Great tool.
And then the TCO Advisor tool, a bit more complex, as you can imagine. But again, there are multitude here of the notes of where information is coming from. It's all out there available, so you can check by yourself as to how we do it. But you start the new TCO analysis, same, like we can do like 30 servers, whatever. So you change the server core count based on, for example, the installation you have, or in the partner case, your customer might have. Select the benchmark out of 2 available, because this is the benchmarking tools with most of the results out there. Click next, TCO time frame, let's say 5 years, fine. Then configure the server. You can configure AMD to AMD, Intel to Intel, Intel to AMD, doesn't matter. Like, it's all information out there. Generically, again, let's say you want to refresh the infrastructure from this system, I don't know, again, randomly, this one. You can modify the price even, so that's fine. Click done. You can add the virtualization software. It does have those vendors out there, I mean, as a choice. So it's slightly, I guess, not slightly useful when it comes to the Windows Server licensing, because that would not calculate it here. But you can play around it with a bit, because you can technically change the subscription pricing in here. But let's say we don't want to add it. Continue. You can configure, you can configure the competitive servers to refresh with the same, like from the competition. Click no if you don't want to. You can use the recommended comparison. Just click recommended, or we can configure it manually. Let's see what the tool recommends us based on similar core counts. Why not? So similar cost, performance, or core counts. Next, 2-socket system, AMD CPU generation. So we want the latest one, fine. And when you click next, it will give you the recommendation straight away. In fact, it does recommend to replace 32-core CPUs with 16-core CPUs. Sven, back to your point, because performance would be pretty much the same out there. But then continue, and you have exactly the same type of scenario as I've shown in the TCO tools, like TCO calculation slides. In here, though, again, this was a random example, right? So I didn't plan it specifically, so it might not be perfect. And in here, you actually use more power. You actually have higher a number of like sustainability metrics because you use more energy, but overall you have still lower TCO. And in here you go from 30 servers to 23. So that's kind of, so it's, again, we didn't plan it. So it uses slightly more power with lower amount of servers, but you get more performance out of the much lower core count. And software licensing here is 0 because we didn't choose the software licensing, right? Mm-hmm. If we would choose it, the TCO will go down even more dramatically considering the cost of licensing included into the conversation. But this is the tool any one of you can use straight away. And I think it was like maybe 9 clicks total. And you can get all of this information with the performance scores, with the breakdown, with everything. And if you click here, generate report, it will give you at the same time a PDF report available with all of the same details and even more. And it will give you all of the background TCO, like footnotes and everything, even more text as to how we compare stuff and what has been compared and what are the results. So this is, again, a publicly available TCO tool we have, and another tool in your pocket you can easily use. I know it has a lot of data and has a lot of details, but whenever you want to compare it really in the detail format, this is the way to go. All right, I think we're on top of the hour. I hope this quick demo was also useful. There are more tools, obviously, available out there, generic, like from the, for example, tuning guides and different other like memory population guides and other things technically. But I'll stop here and just tell you again, first of all, Sven, thank you very much for having me. It was a pleasure. And secondly, if there are any questions from the audience, they can always ask it in the chat or later on reach out to us, and happy to answer those questions.
Thanks a lot, Alexander. No questions so far, but maybe the other days, the following days, some questions will pop up at LinkedIn or so on. So I'm going to share some links and promote the recording of the session over the next couple of days. And if any questions are popping up, so please don't hesitate to ask us. And Alexander is available on LinkedIn as well. So if you want to reach out to him, this is a great tool to do that. So again, Alexander, thanks a lot for your time and sharing all this information about AMD technology. I think it was very helpful to have a very good platform how to decide for the next server architecture you're using in your data center or at the edge. Especially at the edge, we learned a lot about your portfolio. So thanks a lot, and hopefully we meet again soon at some other events about Windows Server and with Manfred Helber. So latest we meet at the Hybrid Conference this year, November, I guess. Was good to have you on the show. So for everyone else watching us today or maybe watching the recording, the next session of Windows Server will be end of January, and Manfred and I will go through the new Windows Admin Center virtualization mode. So the tool Microsoft announced at Ignite last year, November, and we are including all the general news about Windows Admin Center. So you know the virtualization mode of Windows Admin Center is a new tool to manage a huge amount of Hyper-V servers. It's a brand new tool. It's in preview 1. Beginning of this quarter, the preview 2 will arrive. So hopefully at the show, we will have the second release of the preview and can give you a brief overview about what the solution is and give you some insights into available demos. So we will see again end of January. Thanks a lot, Alexander. Thanks a lot for joining the session. And see you soon. Bye-bye.
My pleasure. See you.